This is Geometry Lesson 3.8. Today we're going to talk about point of concurrency and explore how that relates to the triangle. Alright, so a quick review from last session. What point of concurrency do you use to create an inscribed circle in a triangle? And that would be the incenter. The circumcenter would create a circumscribed circle. Alright, so our next point of concurrency is called the centroid, and the centroid is constructed by constructing three medians of a triangle. Now remember, a median is when you construct the midpoint and connect it to the opposite vertex. So I'll need my compass, and first thing I need to do is find the midpoint, and to do that I want to do the perpendicular bisector. So I'm going to do a semicircle, flip it around, do another semicircle, and then I will connect those with a straight edge. Okay, now the only thing that resulted in that I need is that midpoint. I'm going to emphasize the midpoint. Alright, I'm going to do that same thing on another side. Let's choose a different color here. Semicircle. Semicircle. And then I'll emphasize that midpoint as well. Okay, now those midpoints I need to create into medians. So I'm going to take the midpoint to the opposite corner, midpoint to the opposite corner. Now because my other midpoint to the opposite corner would also meet at that point of concurrency, I'm just going to do 2 to speed up things. So this right here would be our centroid. And here's the properties of centroid. The centroid is the center of gravity for a triangular region. So if you were to cut out this triangle, you'd be able to balance this triangular region perfectly flat on the tip of a pencil. And the centroid divides each median into 2 segments, where one segment is half the size of the other. So looking at this median here, let's say that this was a length of 10, let me get a better color here, 10 centimeters, then this length would be 5 centimeters. And here are all of the points of concurrency that we've talked about. So just a quick review. The circumcenter is made from 3 perpendicular bisectors. The incenter is made from 3 angle bisectors. The orthocenter is made from 3 altitudes, and the centroid is made from 3 medians. So the centroid is the one that we just looked at. And then notice we have different triangles here. The points will be at different locations depending on what kind of triangle it is. But will those 4 points ever be the exact same point? And the answer is yes. If you have an equilateral triangle, all the points of concurrency are exactly the same. If you have an isosceles triangle, they do line up in a straight line, but they're not exactly the same point. And this will be the problems that we practice.